Yeah, so welcome all the students to this series of lectures that we will be discussing on digital logic design. And we'll start this series with the topic of number of system. And what is this number system actually? Digital logic, we know that we'll be discussing and we'll be studying this subject because we'll be handling most of these digital devices in coming future. Or when we talk about digital devices, that means our laptop, mobile, desktop, all these devices are digital devices because they are using digital data to transmit and receive the information, or whatever language they understand only binary language. So when we talk about the number system, the binary number system is most popular. Why? Because it is the only number system that we can be understood by the digital devices. Because the digital devices have very low input of voltage, and that is either 0 volt or 5 volt. They cannot have more than 5 volt. Here, the 5 volt is being represented as one in binary, and the 0 volt is being represented as zero. So these two numbers will be there in this particular number system. That's why it is known as binary number system. And there are multiple other number system also along with this binary number system that we will also cover in this particular lecture. So let's start this presentation. Numbers we use in digital electronics. So the outline of this presentation will include counting in decimal and binary, how we will count, and what is the significance of place value. That is very important aspect when we talk about the number system. And along with that place value, what do we have in binary to decimal conversion and decimal to binary conversion? How do we do that? Then electronic translators. What are those electronic translators that we should use and that are being used in our digital domain? And then comes the hexadecimal numbers and octal numbers. Those are the other number system along with the binary number and decimal number system. So what is counting in decimal and binary? How do we count in decimal and how do we count in binary? That is significantly different. A significant difference is there in both of them. Let's discuss what are those. So number system is basically is a code or symbol that we refer to define any number system. In decimal number system, we have numbers from 0 to 9, and that has the base of 10. And in binary, we have numbers from 0 to 1 only, that has the base of 2. So how do I define this? Let's try to understand this a simple phenomena that whenever we talk about any number system, we always look at the base of that particular number system. It is always represented as R. So R is nothing but a base here. That base means it will define which type of number system it is. So we always should look at this base of this, any number which is given to you. So this is called base. And the value of this base will also help us to identify that how many numbers are or how many symbols are present in that particular number system. If it is a if the value of R is 10, let's consider the value of R is 10, then then obviously it is a decimal number system. So how many numbers will be present in this particular number system of decimal? So the numbers will be starting from 0, it will be 0 to R minus 1. So the numbers in decimal number system will be 0 to R minus 1 or in any number system. So here the value of R is 1, R is 10. So that means the numbers will be from 0 to 9 or the symbols will be from 0 to 9. Similarly, in the case of binary, the value of R is 2. So the numbers or symbol in that particular number system will be from 0 to 2 minus 1. And when we talk about when we do the calculation, then it will be 0 to 2 minus 1, that is 1. So 0 and 1 will be only two numbers will be there. Similarly, for octal, we have 0 to 7, and in the hexadecimal, we have 0 to 50. So this is how we represent a number system by looking at the base of that particular number. Now comes the place value. What is the place value and how do we define this place value? So whenever we talk about binary, whenever we talk about binary, yes. So whenever we talk about binary, we always say that it is having the significant distribution of number. Uh, for example, if there is a number that is 1100, so we have a binary number that is a 1100. Now, why we are calling it a binary number? Because it is being represented in 10 form and it is given to you with the base of 2. So suppose this is the number given to you 1100 and you need to identify what is the value of this particular number in this decimal system. So this is a number given to you 1100 which is having a base of 2. That means it is a binary number and we are having 1 and 0 here. Now, if I want to identify that what is the value of this particular number system in decimal, then I need to have the concept, then I need to understand the concept of place value. So each and every place value having a significant number. So this first value, it is being represented at 2 to the power 0. Why I am representing 2 to the power 0? Because it is a binary number. If it is octal, then I will use 8 to the power of 0. Then here 2 to the power 1. Then here 2 to the power 2. And here 2 to the power 3. So similarly, I can go on and on up to how many number of are given in this particular binary number, and I can simply use as many number of place value as I want to define. So like we have in decimal, we have the first unity, then tens, then hundreds, then thousand. Similarly, we have decimal in decimal number system. Similarly, we have in this binary number system. There we use 10 power of 10. So 10 to the power 0 becomes 1, 10 to the power 1 becomes tens, 10 to the power 2 becomes hundreds place value, and 10 to the power 3 becomes thousands place value. Similarly, we use the same concept in this binary language as well, binary number system as well. So when the number is given to you 1100, so obviously at this first position, the ones position, we do not have any number. So the representation is 0. And I am stating here binary as no. There is no binary number is present. Similarly, as two's position, there is no number. But we do have numbers at 4's and 8's position. So what do we need to do? We need to add these two place values. So what is the place value? Place value is 8 and place value is 4. So 8 plus 4 plus 0 plus 0 becomes 2, 12. Okay, understood? For example, let's take a number. Convert this number to a decimal value. Or if there is any number that you want to define, suppose if you want to define a decimal number 1258. So how do you define its place value? Obviously, you define this is the 1000. This is the thousands place value. This is hundreds place value. This is tens place value, and this is ones place value. Similarly, we have to use this concept here in binary. Now, yes. So now you need to convert this number into a decimal number. So what can you do? You can pause the video and do that, or what else that you can, or you can do it right now. So we have this number 110011. Now we know the place values. We know the place values. So what is the place value that you know? Yes. You know the place value that this is one's place value. This is twos. This is fours. This is eights. This is 16s. Right? And this is 32. How do I know that? I know that by putting the powers of 2. So this is 2 to the power 0, this is 2 to the power 1, 2 to the power 2, and subsequently up to 2 to the power 5. We are having ones, that means the value is high at these 32, 16, 2, and 1. So I will add only these numbers, right? So if I will add these numbers, then what will happen? And rest of the values I will put 0. So 51 is the correct answer. This is how you can convert a binary number into a decimal number. And similarly, what you can do, you can convert any number, any binary number by using the place values here. So we do have place value 2 to the power 0. That is ones place. We have 1 at ones and eights position. So if we have ones and eight position, that means we are having 8 plus 1, that is 9. Understood? Similarly, we can calculate for others as well. This is 8 plus 4 plus 2 plus 1, so it becomes 15. This is at 2's position, so it becomes 2. Right? Now, decimal to binary conversion. How do we convert a decimal number into binary? So what we will do, we will just divide by 2. And if you want to convert any binary number, before that, before going to binary to decimal to binary conversion, I wanted to tell you one more thing, that it is not necessary that if you want to convert any number system to decimal, then you should use place value. You can use one formula as well. Suppose there is any number system given to you like that is having an x value, this is x0. Suppose this is x0. You have another number that is x1. You have another number that is x2. Right? So if any number system is given to you in this form, decimal, and then x minus, right? Suppose if any number system is given to you with a base of r. Now, if you want to convert this number into a decimal number system, so whatever be the number system given to you, whether it is binary, octal, hexadecimal, or 5s or 6, or whatever number is given to you, you can directly convert that number system into decimal number system. How do you do that? You will just multiply each and every number with the power of r. So look, this is the decimal point. So this is our center point. Let's consider this our center point. We will start from here only. So x0, this is x0. It will be multiplied with r to the power of 0 because it is the first part from the decimal. It is the first number from the decimal on the left hand side. So this will be our LSB, and we will move towards the MSB. So MSB is most significant bit, LSB is least significant bit. So what I will do, I will multiply this with r to the power 1, and similarly the MSB, that is x2, in this case it is x2, it might be x4 or x5, any kind of number is given to you, and it might be long or it might be short, so this will be r to the power 2. Now what do I have to do with this particular case? It is having x minus 1, so I will add this as well. What I will do, this is x minus 1. I have to multiply this with r to the power of minus 1. So this is the proper formula. You can utilize this formula for all the calculations. So the resultant will be in decimal. Got it? For example, let's take another example. Let's take one example so that you can easily understand this. As we have already converted this number 0010, 0010, we have converted before. Or let's take 1001.1. Okay. So this is a binary number. Now you need to convert this binary number into what? Into decimal. So either you can use place value concept or you can use this formula. And with this formula, you can directly convert any number system into decimal, or you can use the concept of place value also to convert that any number system to decimal. In that place value system, what you need to do, you need to define the place value with the powers of the base of that particular number system. Similarly, in this case, you need to multiply each and every number with the base of that particular number system. So here we have binary. So 2 to the power powers of 2 will be multiplied to each and every number. So we'll start with the first LSB. That is 1 will be multiplied with 2 to the power 0. And we have 2 zeros in subsequent numbers. So those zeros will be multiplied by anything, the resultant will be 0. Still, we will do that. 0 multiplied with 2 to the power 1. Similarly, other numbers, next number is also 0. So we will also multiply 0 with 2 to the power 2. And at last, we have MSB, we have 1. Right? So that MSB will be multiplied with 2 to the power 3. Right? So this one will be multiplied with 2 to the power 3. Now we have decimals, so we'll add another, we have 1 here, and that will be multiplied with 2 to the power minus 1. Right? So now this is your decimal numbers. But before that, we need to solve it. So 1 into 2 to the power 3, this becomes 8. This quantity is 0. This quantity is also 0 because 0 is multiplied with anything will be 0, resultant will be 0. 2 to the power 0 is 1, so 1 into 1 will be 1. So we have to add all of these values that we have calculated. So 8 plus 0 plus 0 plus 1 plus here we have 1 multiplied with 2 to the power minus 1, that is 1 by 2. So it will become 0.5. Right? So 8 plus 1 is 9. So resultant will be 9.5. So this is your answer in